Welcome to Ask and Learn.
So in this question, a student is standing on the floor, and his shoes has a console that is final, and that is 1 centimeter. So his shoe and the floor are actually a capacitor, and the potential difference is just going to be, the floor it's grounded, it's 0 volt. The student has some voltage, and he put his hands or hers or whoever. The student put the hand in front of the computer monitor, and then that becomes a second capacitor. I'll just call this I'll call this C1 because this is C2. Then his hand becomes a capacitor with the screen, because inside the glass of the monitor is 25 kilovolt, and then 25 kilovolt for the student separates this depth monitor of the glass of the monitor. Okay, so we can simplify this question a little bit into a schema. This is a monitor. This is ground, and this part is a student, hand, feet, whatever. Let's just use our imagine. And this is 0 volt on the ground. We have 25 kilovolt on the monitor. A couple of things we know. We know this is 1 centimeter. This is 0.63 centimeter. And we figure out what is the voltage of the student relative to the ground. And the question does not give us all the numbers we need. The question just says assume whatever will be needed. So our final answer might be a little bit different. Like my answer could be different from yours if we made different assumptions and if we found different numbers to plug in. But it should roughly be in the same range. So let's first look at this. We have 0 on one side and 25 kilovolt on the other side. So we're really looking for how the voltage is distributed. So what do I name one? I named this one C1, C2. So we know that the total voltage V1 plus V2 will to V total, which is 25 kilovolt. So what we're really looking for, we're looking for like the voltage between the student and ground. So we're looking for V2. We are hoping to x1 in terms of V2. So we want to have V1 in terms of V2. How do we do that? Well, these two, okay, so this solid island since the electrons of this person, it has a total charge of 0. That means total charge C1 should be equal to C2V2. So we know V1 equals C2V2 over C1. Okay, that's how we express in terms of V2. And we can plug this into this equation so that we know C2V2 over C1 plus V2 equals V total. So V2 equals C1 V total of C1 plus C2. So how we find it. So now what we need is we need to figure out what is the ratio of C1 and C2. So capacitance C equals, let's find out what C1 is. Epsilon naught times K times area over D. This is definition. And epsilon K2 A2 over D2. Simplify a little bit. We have K1 A1 D2 and K2 A2 D1. Okay. K1 is K of the monitor, K of class, And if we look it up, it's roughly 3, I think. K2 is K of wait, is this right? Sorry, the glass is more like 5. Oh, it's 3. Upside down. Yeah, the K of vinyl is roughly 3, and the K of glass is roughly 5. And then A1 is A is here, so A1 area of a hand, and A2 is like the feet. For me, my feet is roughly like 1.5 times the size of my hand, maybe 2 times, probably 1.5 times. But I'll just do 2 to make it easier. So if my feet is twice the size of my hand, and then but this student only has like 1 hand on the monitor, but he's standing on 2 feet. So the area of feet to hand will actually be 1 to 4. So times 4 times 1. Final distance, this we already know. We have 0.63 millimeter. 0.63 millimeter, 0.63, and then the depth of the shoe is 1 centimeter. So if we calculate this is roughly 2 over 3. Roughly, because this is 5. This is like 3 times 2.5. It's like 2 over 3. So I just use this ratio and I'll put it here. So, this is roughly 2 times 20 over 5. B is 25 kilo ohm. Kilovolt, sorry. So this is around 10 kilovolt. So that is the voltage of this with respect to the ground.